protocols, right?
Yeah, we're not going to talk about all of them. We are going to talk about DNS, and we are very briefly start discussing about FTP, HTTP, and email, and that's going to be all of it. So, okay. So let's start with this. Application level protocols. These are applications which are still part of the TCP/IP, let's say, kind of suite of protocols, but they're not integrated into it. They are most of them, I mean, all of them are acting at the application layer. And the most important one that we are going to discuss today is the DNS, or the domain name service. And this one is important because we could not see, I mean, we cannot see today an internet working without this service. Why? Because it helps translate, it helps translating machine names, something like www.cs.ubbcluj.ro into an IP address. And without that, we will be required to remember a lot of IP addresses of all around the world services, and this is not something we can do easily. Or we would be required to at least remember the IP addresses of some search services, which again would mean that those search service providers will not be able to change their IP addresses, and again, this is not feasible. So, okay, let me just discard and write again. So for the DNS protocol, we know, or is there anything you already know about the DNS protocol from your general culture? What can we already say about it?
It translates names to IP addresses.
Yes, and it does the vice versa as well. For most of the time,
Yeah.
when you have an IP address, it's also able to provide you at least one machine name that responds to that, or that is linked to that IP address. And what we need to know now is that this name here has a structure. This representation here with dots has nothing to do with, it's different than the dots in the IP address. They're not related in any way. They just represent here some sort of hierarchical way of presenting information. And that this information, the name to IP, IP to name, and other things are all stored in some sort of distributed database. Okay, this information is not stored in a single unique database on internet, but it's stored in some sort of distributed database. And because this database is distributed, well, there are various reasons for which this database is distributed. First of all, you would like, if you own a domain, for example, one name which is reserved for you, you would like to handle that information yourself. I mean, you will need to be able to add machine names into that domain or subdomains into that domain. You will need to change correspondence from name to IP addresses yourself and not being required to delegate that to some other organism that could take days before it can change anything if they would handle the entire internet. So with this in mind, the naming system is hierarchical, which means it has some structure into it. And we start reading it from this part here, top level domain. The part to the right of it is called the top level domain. And if you want some example, we have some ro.com and .edu, whatever. We have a lot of names which are already established. They are provided as they are. They exist. And then we go to as we go to the left, these are domain names. These are names that you can invent yourself. And you can actually buy them. Once you buy a domain, for example, if we bought at the university UBB Cluj name, and it's stored inside the RO TLD. Okay, so we bought ubbcluj.ro and UBB Cluj domain inside the RO top level domain. That means we are reserved this domain, and whatever it's left here, it's something that we manage once we bought this domain. And we can invent machine names or subdomains for that reason. We can have hosts here directly, or we can have subdomains. We will see how they are linked together. But this part from this here, it's user managed. Okay, this one here. And altogether, when you have a complete name, that is called a fully qualified domain name. Okay, when you have www.ubbcluj.ro, this is a fully qualified domain name. We can refer to this machine by a single simple name, local www, but this will only have meaning inside our domain for us. It will be some machine which is the web server for our domain. It doesn't have any meaning outside our domain. I mean, outside our organizations, because there are other many wwws for all the other domains that exist there. So there is a need to have this naming system, and the initial implementation at the beginning of internet, it wasn't distributed at all, or it was distributed, but each one had a local copy, if you want, of a master database file, and it was a so-called host file. And this host file is something that you can find, for example, on Windows. There is one on all operating systems. Windows, if you go in System 32, there are still remainings of it. These drivers. Come on. Drivers, etc. And then you have this file here that you can open. And you have some sort of IP addresses to machine name correspondence. These are all commented here. I don't have anything in mind. But if you do put here something, then this will be taken higher priority than the DNS system. So whatever you store here, it's like you override the DNS system. And there are on Linux as well. On Linux, if I would be to show you those. Okay. There is an etc hosts file on all Linux systems, and then it has the same structure, IP to machine names correspondence. For example, this one states that 172.30.0.4 it's Linux and it's Linux scs.ubbcluj.ro. That's the fully qualified domain name. You can edit it exactly as on Windows. It's a file, and you can add records to it. Okay. It was a host file at the beginning, but then as internet grew, it was more and more difficult to handle this file, to update it and distribute it to everyone. So eventually the system got a hierarchical structure and became distributed. And if we look at it, the domains are kind of organized like in the figure below. You have some sort of generic domain names. These ones here, top domains, sorry. Top domains, these ones. So not update layer. Something like that. And we have then country based. I can draw them with a different color. Each country has a top level domain. For us, it's .ro, and these are the top level domains. Then as we go down, we have domains here. So it could be UBB Cluj here somewhere. It will be here under RO, for example. And then as we go down, well, we can add subdomains to it. And we read it from bottom to top, robot.ai.cs.yel.edu. Now, it's distributed this way because, in fact, the DNS database is stored kind of hierarchically. It's distributed, but the database is hierarchic as well. So what we will do, as we will see, if we want to learn information about this machine here, is to identify its top level domain. And there are so-called, in the world, there are so-called root DNS servers. These are hosted by either some organizations or by very large companies like Google, Facebook, and Cloudflare and things like that. And there are between 16 to 32, whatever, it doesn't matter. It could be more than that, root name servers. They are called A-root, whatever, something. And they know information about which DNS servers hold information about, for example, com. Well, you'll ask one root domain name service about the domain com if you want to query something into the .com domain. If you want edu, again, you will ask a root domain name server. That root domain name server will tell you, okay, I'm not able to tell you all about your machine, but I am able to tell you one DNS server that's handling .edu. Then you go ask that name server about information of the domain Yale. And it will tell you, okay, I don't know how to handle that, but I know a DNS server that can tell you something about what's happening in Yale. And then you go to that DNS server and you'll probably find cs.ai.robot. The other components will be answered directly by that name server. So it's distributed and you need to query multiple DNS servers in order to infer the information that translates that to whatever 173.21. Whatever 15.61, let's say. This is a little bit of an overview we had on how DNS is organized. And now, who manages this. And how? Let's look a bit look a little bit at from the administrative point of view how this is managed. Well, there is some sort of there are some sort of organizations. ICANN, Internet Corporation for Assigned Names, setting doesn't come from the fact that he can do something. This is its name. This is the organization that globally and at the beginning started managing domain names. Whenever you want to buy a domain name, you need to tell somebody, such an organization, to an organization like this, okay, I want a domain name. And you would verify that the domain name is not already taken, and that organization will also do the same. For example, if I want to buy ubbcluj.ro, that organization will verify for you that the domain it's not already bought, is not existing, bought by somebody else. If it's not existing, it will register it to you. You'll pay a fee. It will register it for you, and that register, this is called the register as well. This is called, and this is the job is done by the register. I can supervise. It's supervising all these. Yeah. Okay, its role it's only to supervise all this information. Domain registers are the actual companies supervised by ICANN that will register ubbcluj.ro. It will store it somewhere and it will assign this domain to UBB. You will need to pay a fee, and then that name is assigned to you, and you will have one of the DNS servers of the register that maps ubbcluj.ro to a UBB DNS. You'll need to provide yourself a DNS server that will host whatever is inside that domain. Okay, that X, whatever you store inside that domain will be managed by a DNS server that you need to put into place. The complete list of registers, you have it at this URL. This is not such important. That important is this is just for you to understand how do you actually register a domain. Well, you contact the domain register. You can go, for example, rnc.ro. There are something like, well, there are plenty of them. Just look for domain registers, and what you actually do, you take a look how expensive is a domain name that ends into a specific TLD at every of those registers. For example, a .com nowadays, .com is roughly $12 or euro in Europe. So whatever you buy under .com, it will cost a yearly fee of 12 euros. .ro, it's about the same, between 10 and 12 euros per year. So with that, the registrar will register that name to you for 1 year. If you don't pay at the end of 1 year, well, that domain is dissociated from you. And then because the register no longer keeps this thing, your domain, even though you have this database, but if you don't pay, you don't have the glue from the top level domain DNS servers to your domain server, then it becomes irrelevant in the internet, your domain name, because nobody can reach your domain afterwards. We will see how the queries are done and you'll understand. So you contact the domain register, you choose a unique name. You can also, if a domain is already taken, there is a Whois service, which is usually web-based, but there are command commands in the command line that help you do the same thing. This one on Linux, whois, and you type a domain name, and it will give information about who is the physical person or incorporated person that owns that domain. As I told you, then you pay the fee and you get and you need to provide two, and that's two DNS servers that will store information about your domain. Okay, so whenever you buy a domain, you need to either provide or have somebody provide for you two domain servers that will hold your part of the distributed database about your domain. Why two? Because if one becomes unavailable, well, the other one should be able to answer. And they are actually, or the standards say that the two DNS servers should be geographically apart. So, for example, we have more than two at ubbcluj.ro, so at least two. And we have one DNS server in the main building of UBB. We have another one in another building, and then we have another two in Bucharest. So if, for example, there is an earthquake in Cluj or something happens with our servers here, or if there is a fire and the main building goes on fire and everything is destroyed inside, we still have the ones in Bucharest. The same happens if the location in Bucharest gets destroyed, we still have DNS servers up and running. So for disaster, that's for disaster coverage. If you want to see what whois information, what type of information the whois is providing, here you have an example for ubbcluj.ro. It's a little bit dated. And nowadays, you don't get all of this information. I mean, because of GDPR in Europe, you don't get any more the names and phone numbers of the physical persons, but you do get the owner of the domain. When you type whois ubbcluj.ro, either on a website. If you go on a website, just type whois on Google and you'll find lots of whois servers, and you learn who is this domain belonging to, and these are the name servers that are provided by the client, by the client that owns ubbcluj.ro, and that store information about this domain. Okay, so you see we have 1, 2, 3 with their 3 IP addresses. You need to provide them with their IP addresses, and those IP addresses should stay fixed. Or whenever you change them, you need to change them into the whois record. And this record, as you can see here, it's belonging to this register, row TLD. That's row top-level domain. There's nothing special. It was the only organization at the beginning when Romania entered the internet era that handled these things. And the remaining of it is just information about the administrative persons that are handling the domain, and so on, so on, so on. Here, phone numbers, and you have, these are actually the logins, I mean the users that are managing, is the user of this that is managing the administrative information. And it goes on a second page as well, and you have all this information about the ownership. Okay, that's all. It's not very complicated. Anyone can read it. DNS servers, entity that owns it, and then some contact persons or administrative person that are actually maintaining this domain. Now, on the software part, we have the DNS is organized from 2 components. One, a resolver. That's the component that you're interacting with when you're actually doing a get host by name, for example. You're actually talking to a resolver, the resolver part from the DNS, and a name server. That's the one that it's actually holding a part or your part of the distributed database. Okay, so you have a resolver. If you don't have a domain name, you still have the resolver part. This one is implemented in all operating systems, the resolver part. So whenever you call get host by address, get host by name, this is the component you're calling from TCP. And this resolver goes and asks various DNS servers about the information that you're asking. And then it comes back with an answer if it has one, or a null answer if it doesn't find anything about the machine name that you're asking information about. Now, the DNS server is a separate component that you install on Windows. It's not available by default. It doesn't come with Windows. It comes in only as an optional component with only the server part of the Windows operating system. So you need Windows Server. On Linux, you can just install it, but obviously you can install on Windows third-party components, DNS servers, and they are piece of softwares that are managing the database. They have the database managed and read by this component. So they read into memory some database that you specify in some sort of files, and then they answer queries when they are asked about. Okay, so the entire database is stored inside the DNS server, and then the DNS server is answering. Actually, this is how it works. Okay, your application, it's calling the resolver part, which is part of the operating system. The resolver part goes and talks. So this is API here, and this is DNS protocol as dialogue between the resolver and a DNS server. And then you get back an answer, which is provided back to you. Okay, these are things that we've already discussed. For each domain name, I told you that you need at least 2 DNS to provide at least 2 DNS servers. One of them will be called the primary of master. This is the one that actually stores, that you actually update. Whenever you need to manage the information inside, you'll put it into the files that are into the database that it's managed by the primary, and all the others are called slaves or secondary, and they will just mirror that database automatically, so that you don't have, if you have 6 DNS servers, so that they do not become inconsistent because you do one change on one of them, and you do this for the same name, you do a different change on a different one. So you update just one, the other ones are going to automatically mirror that information, and then they will answer based off that information. What are the goals? Well, the goals are to create a global, scalable, consistent namespace by having some sort of distributed database that you'll need to interrogate. Another goal is to have local control over local resources. So ubbcluj.ro, I need to be able to manage it and change it whenever I want. And we want a distributed design to avoid bottlenecks, because if I would have everything stored centrally, that means I will need a lot of resources, computing side, in order to be able to answer all of the internet from the single global database. Okay, we don't care about the others. And now, how are things actually happening in practice? Suppose I have a browser and I want to connect to www.yahoo.com. And I'm on a regular PC here. And my browser and I want to connect to this machine. Now, there are, I told you, about between 60 and maybe 64 root DNS servers. And these are known somehow into each OS, by each operating system. Each operating system has a list of static, at least 8 IPs of root DNS servers. And normally those do not change, but they don't keep information about a lot of things. The information that they keep is just about the top level domains. So the first thing my browser will do, it will separate this part one, and then ask the root server for the .com about the .com domain. Okay, that part that I isolated, and suppose it gets back that the DNS server that it's answering .com, it will be this one, agtld.servers.net. Eventually, this was a real example, so this is one of the servers that handles .com. So then my resolver goes and asks agtld.servers.net about the DNS server of yahoo.com. It goes on the second component. Let me throw it with a different. Okay, it goes to the second component, and then it asks that here too. It asks that DNS server, and it gets back that the name server that is handling that domain is this one, and it knows now that yahoo.com it's handled by ns1.yahoo.com. Okay, you see that it's already belonging to Yahoo, this DNS server. So it goes into the third step and asks DNS ns1.yahoo.com about www.yahoo.com. Okay, so this is the third step that we have here. And that DNS server here, it's telling me that www.yahoo.com, it's nothing else but a name, a given name for another name. It's an alias if you want, for this one, www.yahoo.akadns.net. So finally, in the fourth step, my resolver will go and ask information about this machine here, and it will get its IP address. And this is how involved the process is, because we need to traverse that hierarchy of DNS servers. You need to ask a root DNS server about the top level domain. Then you need to ask that top level domain DNS server about the domain name, and then the subdomain, the subdomain, and so all the machine names or the machine name. And then you'll eventually find the information. Usually you can expect for something like www.ubbclose.ro to ask one top level domain, then one, you'll ask first a root DNS, then a TLD, and then at least a regular DNS. At least you'll have at least 3 queries to do. One from the root DNS, the second one to learn about the domain name from the TLD, and then from the domain itself to infer information about www.yahoo.com or about www.ubbclose.ro. So there are at least 3 queries. And these queries could be non-recursive or recursive. I mean that whenever you're asking a question, that you're asking that question to a DNS server. And that DNS server, for example, if this is the client they have here, and I have my, let's say, resolver, and I have a local DNS server here. And I want to ask to get information about this domain. The query could be recursive. I mean, I could instruct the DNS to do a recursive query or an iterative query. And if the query is iterative, that means I ask the first DNS server, my DNS server, and he will go to the root level DNS server and get back an answer. And then my DNS, which with my resolver it's working with, will go again iteratively and ask the second one, the third one, and so on. And when I finish it finishes, iterates on all of them, it gets back the information to me. Or if the information, or if the query, if I ask the DNS server here to have the query recursive in a recursive way, that will behave a little bit differently. Recursively. That will be done like this. It will go here, but because it's asked recursively, I will ask this one to go recursively and ask the next one, and I'll ask, and this one is asking this one to go ask this one, and then the answer are coming back this way and this way. Wait a minute. Okay, the flow of information is different depending of the fact that the DNS query is asked recursively or iteratively, in an iterative way. Now, usually, local DNSs, the ones that I have, for example, these are in my domain, will be in my domain. So here are my DNS. That will be my DNS server with my host that is asking. Usually, you can expect that a local DNS server, this one, to handle recursive, but the other ones, usually in internet, will not handle recursive queries for you, because that means they will need to do the work for you. So nobody is going to be willing to do the work for others. Instead, they will just they can refuse a recursive query and tell you that you need to go and fetch that information yourself, even if you ask them to do that thing recursively. So in practice, most of the people are going to ask here recursively. This one will accept it. It will ask this one recursively, but this one will say, okay, I'm not going, there is no way I'm going to do that work for you. So it's just hand you some information, then you'll need to go and ask all the others. You can ask them recursively, but they will refuse and just tell you that you'll need to go by yourself and fetch that information exactly like the black lines are depicted here. There is a, not sure it's working anymore. Yeah, I don't think it's working. There was an example applet that would show you how this is working, but I say, or I don't have Java probably installed. You can go. You have the link into the lecture, and you can click on it. It's an applet that shows you how recursive versus iterative is actually happening when you have 3, 4, 5, 6 steps to perform, and they are colored differently, and it's kind of nice to see how that information is get back. Now, in order to configure, what time is it? I still have 5 minutes. In order to configure the DNS, well, you need to provide, as already discussed, a DNS server, and you need to store the DNS information in the so-called zone files, which is a text file. And you'll store information about one or multiple domains there. And then you need to store that database onto a DNS server, load the DNS server software that will read those files. And let's go skip this part. And then inside those files, you have records. And there are multiple types of records. For example, you have type A records inside those TXT files and those text files. And those are mapping host name to IP addresses. Then you have NS records. These are the ones that are telling for a domain name, which is the name server, the IP of the name server, or the name of the name server that is actually managing DNS information about that domain. So an NS record will tell you the DNS, the DNS server for that domain. You have another type of record, CNAME, which gives something which is called an alias, so another name, canonical name for a given name. For example, we have www.cs.ubbcluj.ro. You'll find probably that that's just a CNAME for nesi.cs.ubbcluj.ro. That means this is just another name for this physical machine, which has an IP, and you get that. MX, it's email. Well, this one, it's part of the mailing system, email, the way email is working. We will discuss briefly about it. And it tells me for a given domain who are the email servers where I can send email in when I'm, for example, when I'm sending email to, let's say, george@ubbcluj.ro. Well, the MX record will give me something like mail.ubbcluj.ro, and that means whenever I deliver mail to this user here, I need to deliver it to that server in order to be actually forwarded to the real user, which is behind that name. And the various types of records that are possible, you have them here. Start of authority. This one describes, this one is a header like in the database, and it describes the DNS file. For which domain is it, who administers it, and so on. You have type A records, as we discussed, MX, NS, CNAME, and then you have some which are not as used as, I mean, not all of them. You have PTR, that's the inverse, that's IP to name. Okay, that's the reverse of A. And then you have hinfo and txt. These are more informational stuff. These are some host description and text description about the domain. Okay, they are not usually related to querying some information about the host. It's just that you can store there some information, additional information about the domain. This is the way it looks. As if you want an example, a DNS file. So for this domain, utcluj.ro, you see this is the SOA part. Exactly this part here. This is the SOA part. And there's various information that you can infer from the SOA part. It's required. This is mandatory in each. You should have at least one section per domain. One section SOA per domain. And it tells me that it manages this domain. It tells me that probably the person that can answer emails about this would be this one. You need to replace that dot with an @ It has some information here. These are various information pertaining to the working of the DNS. For example, the serial number tells me the version of the database that I have. I mean, whenever you update something here, you update the serial number, you increment the serial number. And that serial number is used by the slave DNS servers in order to know that, okay, there has been a change into the DNS file. Let me get that change. Let me synchronize the entire database to my version of the file. So they are just updating themselves by using the serial number. Then there is the refresh number, the refresh interval. This is given in second, and it tells other DNS, slave DNS servers, or slave DNS servers, how often should they refresh, should check for changes on the master DNS. Okay, this is 36,000, which roughly is 10 hours, I think. then if they're not able to refresh because the master is not answering for some reason, or because maybe there is no connectivity between the slave and the master, how often should they retry that operation? And this the amount in seconds as well, that tells if by any reason you cannot update your information within this time interval, then you don't answer anymore. It's all the information that you have, it's expired and you don't answer anymore to it. And then there is this information here, minimum time to leave. This is in seconds, it's not like for routers, seconds as well. And it tells me how long is a record that I've got from a DNS server valid. For example, for if I'm a host and I'm interrogating this DNS server and I'm getting a TTL for a machine for this record, for example, to be this amount of time, that means that it's valid for 100 hours. This is 1 hour, 10 hours, 100 hours. So for that amount of time, I can cache that answer, and whenever the same PC is asking it again, well, I will just give the local copy of the cache within 100 hours, because this is the amount that was specified in that DNS server. It's the DNS server or the manager of the DNS server that knows for how long its records are valid. Okay, let's take the break, and then we'll spend another 10 minutes after the break, and then we will be discussing the administrative stuff. If you have any questions, I am here. You can ask them, and we can discuss over them. So this is the information in the. Let's continue shortly. This is the information contained in the SOA file, and then we have actual DNS records. Type ns.edu.ro. You can see that the main one, which is the master, is also specified, the master DNS server, this one. It's also specified here. And then you have some utcluj.ro has other 1, 2, 3 DNS servers. It has one MX record, that's email. And that tells me that everything that has something utcluj.ro should be delivered to this mail server here. So that means that that machine should implement some sort of mail server software that actually takes the email from another machine and stores it temporarily until the user reads it. And then we have some various A records, some CNAME, and there are now PTR records. Okay, about the DNS protocol. Now, all this information it's queried and transferred between DNS servers and between resolvers and DNS servers using the so-called DNS protocol, which has a packet. It goes over UDP, usually port 53. And I won't enter into details. You have some sort of, this is the structure of a packet. You have some ID, some flags, some number of questions, some number of record sets, some number of authority record sets that are from master servers, and additional record sets. And then you have the actual questions and answers. And this is the structure of a DNS packet. And then depending on the query type, you have different fields inside each query. For example, if the query it's one of these types, we have a query name. For example, you can put here www.utcluj.ro. Query name would be A. query class will be always internet. And then this is the question, and you'll get back the result, something like this. And you can see here you'll be provided a TTL. How long is that answer valid? The type will be for A here. Class will be internet, and you'll get, I don't know, you'll get the same name here, www.utclosure.ro, and you'll get here the record length, the number in bytes, number of bytes of the answer, and you'll get here whatever one, I don't know what was that. www was, okay, you will get that it's a C name in fact. So Orion, you'll get here C name. No, not here, sorry. So here you'll get Orion, whatever in answer. And then these are the information which are translated in, are transferred in between domain name servers when they're asking one each other, or between the resolvers and the domain name servers. This is all about the DNS system. You should, this gives you a rough picture of its structure, its purpose, and how it's working, its components. And for the rest of it, you can read into the book that I gave you into the textbooks. An additional protocol that could be used for file transfer is FTP. I won't enter into details. You can read about it. It allows you to exchange files between two machines. And usually you have an FTP client, an FTP server, and then you connect from the client to the server, and you store files and you retrieve files and you list files. I won't enter into details about this one. The most important, the more important ones are the SMTP and www, or web. SMTP, the SMTP protocol is the one that handles email. SMTP is the service. It's the service implemented by MX servers. Basically, when you want to send email, for example, you are here, a user, and you want to address email to a specific user, for example, abc@google.gmail.com. Well, you will ask who is the MX for that domain, and you will get a machine name, for example, mail.gmail.com. And then once you get this, you send your email to your local, this is my local organization. Your email will be delivered to your local mail server, and the local mail server, in fact, you will get this information. And then the local mail server is the one that you configure into your email client. For example, when you configure a software, something like, let me see if I have one configured here. Yes, I have one. If you configure, for example, I have an account configured here. Okay, if I want manage accounts, advanced. How do I do the advanced part? Incoming. Okay, so whenever you configure an email account, you need to provide a username, a password, and you need to provide an incoming email server. That's the one that's temporarily storing the email for you. And that's the MX, in fact, that will get the email for you, and an outgoing email server, which could be the same, or it could be a different one. And in fact, this one is the local mail server to which you send email and tell him, okay, this is the email I want to send, just handle it. And this is from where you read your email. These two things, you always need to specify them. And in fact, in my case here, I will assume that the two of them are the same as this one. Okay, outgoing email server is the one to which I am sending email from my Windows machine, and tell it, okay, just send email to abc.gmail towards abc@gmail.com. And what this mail server does is asking the MX record. It infers the mail server of the other domain and supposes this one, and it will, if this one is mail.gmail.com, and it will actually send the email to this email server, and this email server then will store it temporarily until some user on the other side will actually abc@gmail.com will actually go and fetch that email. So email without DNS, it's not possible, because you need to learn which one is the mail server for each domain that it's on the right side of your email address after the @ sign. So on the left you have the user, and at the right you have this mail server. I mean, you have the domain, which is identified by mail server. Email is working on port 25. I could show you something by the end of this lecture if you still have time. It's an offline protocol, and you can read more about it later on. And yeah, let me just not do this. Okay, so now in fact, you see the steps that you can do in order to send email as somebody. I will show you an example if I have the time. And then there is the HTTP protocol that I wanted to tell you about. This is for transferring web pages from a web server to a browser. They are using HTML language. So pages are written in HTML, and the protocol used to transfer is HTTP. HTTP works over, as you already know, port 80 TCP for plain text, or over 443 TCP SSL when we are talking about HTTPS, which is encrypted and authenticated. Authenticated means that the browser, when it goes on over HTTPS to google.com, there is a mechanism that allows my browser to verify that I'm actually connected to google.com. There is a mechanism that allows me, like, for example, we have our ID cards. If I meet somebody, if I meet you during the exam and I don't know who you are physically, I can ask you to present me your ID card, and I'm looking into your ID card, and I'm then positive. I could positively identify you as being the person you claim to be. Okay. HTTP protocol, it's again some sort of text protocol, even when encrypted behind. If you decrypt it, it's just a text protocol. For example, when you fetch a page, you do a command like this: get the root of your URL, and then you specify the protocol, and then the server provides you the page. For example, once you connect it to a web server, get index of the HTML will give you HTTP 1.0 will give you the web page, this one. I won't insist over it because I want to finish this. I won't insist over it because I want us to have time actually discussing about the examination and all the related stuff. Now, if you have any questions, we can start discussing. If you want, I can also show you how to send email to somebody. For example, what a mail server will do for you when you tell it to example, I am on Nessie. I think Nessie has a mail server, and if I connect to it, yes. Hello, CS UBB Cluj.r. Not on the right screen. Let me share with you a different screen. So share now. Screen 2. And so if you want to see what a mail server is doing when you send some email, you need to, it does this, hello cs.ubbcluj.ro. This is the first thing you do. Then mail from, let's say, daddy@cs.ubbcluj.ro. Okay, it says okay, RCP to recipient to, whatever you can, Adrian done. Okay, now this is not going to let me erase that. Let's do it. Let's do some fake. In fact, let's do mail from Trump at White House Gov. Okay, I need to disconnect and do that again. Hello, cs.ubbcluj.ro. Mail from Trump at White House Gov. Recipient to see what is possible actually with the email system. If you have access to a local one which allows you to send from like anyone, like in my case here, to daddy@cs.ubbcluj.ro. Recipient to daddy@cs.ubbcluj.ro. Oh, come on. Recipient to. Okay. And data. So from to, and then from, I need to type what is going to be shown into the email client to daddy at, this is just text information. It doesn't care what you put here. Subject. I come over. Hello. Come visit us at the Capitol. Okay, and then put a dot at the end, and the message was accepted for delivery. And now, if I look into my email client, at some point, I should get some email. Whenever it comes in, I will show it to you. I sent it to daddy@cs.ubbcluj.ro, so it should arrive at some point. Yeah. Okay, and this is what I've got into my email from Trump@whitehouse.gov, and I have a message. It's like it's coming from Trump, but it's in fact I just misguided my mail server to send it to impersonate this person. Now, there are various techniques to stop people from doing that, but just pay attention that email, you cannot always trust the sender of the email. If you want to trust it, it needs to have some sort of signature or some sort of other mechanism, security mechanism that we usually learn during the specialized protocol lecture, which is an optional lecture next year. So that was the things that I wanted to show you. For the remaining of this class, I will answer questions. I will stop the record, and I want to